Happy day, children. Very nice to see you in front of your TV to see yet another episode in KalviTv program. Today we are going to see part 3 of the lesson Carbon and its Compounds. We have already seen the first two parts. Today we are going to see about two important compounds of carbon, and the first one is ethanol. Alcohols are very important compounds of carbon, but the most important one among the alcohols is ethyl alcohol, which is its common name, and the IUPAC name is ethanol. We come across this alcohol in our day-to-day life. It is found in alcoholic beverages and also in the cough syrups which we use when we get sick. Let us see how this important compound of carbon, ethanol, is manufactured. Ethanol is manufactured from sugarcane juice. Sugarcane is used for preparation of sugar by the process of crystallization. Once the sugar has been crystallized, the remaining liquid which remains behind is called as molasses, which is a dark colored syrupy liquid which still contains around 30% of sucrose, which cannot be removed by crystallization. So, from this molasses, the ethanol is prepared by diluting it first to about 8 to 10%. And to this liquid which is diluted, we add a nitrogen source like ammonium sulfate or ammonium phosphate, which acts as food for yeast. The entire content is transferred into a large tank which is called as fermentation tank. The temperature is kept at around 303 Kelvin. Yeast is added and it is allowed to stand like this for a few days. During this time, fermentation takes place and the ethyl alcohol is produced. It contains about 15 to 18% of ethyl alcohol, and it is subjected to a few processes of purification. First, this fermented liquid, which is called as wash, is made to undergo fractional distillation. After fractional distillation, the main fraction which is produced is called as rectified spirit, which contains about 95.5% of alcohol and 4.5% of water. This is further purified by making it get refluxed over quicklime for about 5 to 6 hours, and it is allowed to stand for a few more hours. When we get another portion of this mixture which is further subjected to distillation, and we get what is called as absolute alcohol. As the name says, absolute alcohol contains about 100% of alcohol, which is the pure form of alcohol. That is ethyl alcohol. Let us see what is the chemical reaction that takes place during the process of fermentation. You can see on your screens that the sugar which is present in molasses is given by the formula C12H22O11. This is the formula of sugar. So, the sugar is first converted into glucose and fructose, which are simple sugars, by an enzyme which is invertase present in yeast. There is another enzyme which is present in yeast which is called as zymase, and this enzyme converts glucose or fructose into ethanol and carbon dioxide. It is because of the formation of carbon dioxide that we can see the bubble formation in the fermented liquid. So, ethanol is manufactured from sucrose in this way. Let us now see what are the physical properties of ethanol. It is a colorless liquid and it has got a burning taste. It is a volatile liquid. Volatile means easily vaporizable. Therefore, it vaporizes easily, and it is completely miscible with water in all proportion. Miscible means it will easily mix with water. So, these are the physical properties of ethanol. Let us see the chemical properties of ethanol. Dehydration, which means loss of water. Dehydration means loss of water. So, what happens when ethanol undergoes dehydration? To remove a molecule of water from ethanol, concentrated sulfuric acid is added and the temperature is 443 Kelvin. At this temperature, sulfuric acid removes a molecule of water from ethanol and ethene is formed. The formula of ethene is CH2 double bond CH2, which is the first member of the alkene series. The reaction of ethanol with sodium. Sodium reacts with ethanol. The hydrogen in the OH group is replaced by sodium and hydrogen is given out in the form of hydrogen gas. So, hydrogen gas is a byproduct of this reaction and the main compound formed is sodium ethoxide, whose formula is C2H5ONa. So, the hydrogen present in the alcohol group is replaced by sodium to give rise to sodium ethoxide. The next reaction is oxidation of ethanol. Oxidation of organic compounds is mostly carried out by using alkaline potassium permanganate or acidified potassium dichromate. Any one of these two oxidizing agents will convert ethanol into the corresponding acid, which is ethanoic acid. So, ethanoic acid is the product formed when ethanol undergoes oxidation using any one of these two oxidizing agents. There is a color change which takes place during this reaction. Potassium dichromate is orange in color and once the reaction is over, the solution becomes green due to change in oxidation state of potassium dichromate. Therefore, this reaction can be used for the identification of alcohols also. The next is a very important reaction which is called as esterification. Esterification is a process by which an acid, that is a carboxylic acid, reacts with alcohol to give ester and water. Esters are having a fruity odor. Therefore, during esterification, a compound with fruity odor is formed. When ethanol reacts with ethanoic acid or acetic acid in the presence of concentrated sulfuric acid, ethyl ethanoate is formed with water. Ethyl ethanoate is the ester which gives a fruity odor. So, the reaction here is between the functional groups OH of alcohol and the carboxylic acid COOH. A water molecule is removed and a new functional group, that is the ester group represented by COO, is formed in this reaction. The next reaction is dehydrogenation. When we said dehydration, it was removal of water. Dehydrogenation means removal of a hydrogen molecule. This takes place by heating ethanol at 573 Kelvin over copper. A hydrogen molecule is removed from ethanol and we get acetaldehyde and hydrogen. Now, acetaldehyde is an organic compound with a functional group CHO. So, from ethanol we can get acetaldehyde by making it undergo reaction with copper at 573 Kelvin. The next reaction is what we call as combustion. Combustion means burning. A substance burns in oxygen. We call it as a combustion reaction. As we said in the properties of ethanol, it is a highly inflammable liquid. It is volatile and it is also highly inflammable. When it burns in air, it combines with the oxygen to give carbon dioxide and water. So, combustion of ethanol or the burning of ethanol gives carbon dioxide and water. So, these are a few chemical reactions of ethanol which we have seen. Let us now see what are the uses of ethanol. Ethanol has got a wide variety of uses. The main use of ethanol is it is having antiseptic property. Because of this antiseptic property, it is used for making hand sanitizers. We know the use of hand sanitizers at this time when it plays a very important role to kill the coronavirus. So, in hand sanitizers, the main component is ethanol. It is used for making medical wipes, which is having a moist paper, and it is used for cleaning it since it is having some medicinal uses. Ethanol is used as a solvent for the preparation of dyes, so many fats. It is useful in dissolving all these type of substances. And the main use, we can see the picture of vanilla essence on your screen. It is got from the vanilla beans. So the vanilla essence is present in the vanilla beans. When the vanilla beans are soaked in ethanol, ethanol acts as a extracting agent for removing this vanilla essence from the vanilla beans, which is used for enhancing our food flavors. So ethanol is used as a very good solvent. It also acts as a extracting agent. It is used as an antifreeze in automobile radiators. Automobile radiators contain water for cooling the engine. In cold countries, we know at 0 degrees centigrade, the water will freeze. And in cold countries, to the automobile radiators, when ethanol is added, it reduces the freezing point of water to below 0 degree centigrade. So the water does not freeze even when the temperature goes much below 0 degrees. And this is the added advantage. It also helps to prevent the corrosion of the engines and helps to act as a cooling agent. So this is the use of ethanol as an antifreeze. It helps to reduce the temperature of freezing because of the interference between the two liquids. The freezing point of water is lowered. Now there are 4 important types of ethanol. The first one is the denatured alcohol. Denatured alcohol is ethanol mixed with some substances like pyridine, copper sulfate, rubber residue, which make it unfit for drinking, and therefore it has got a large number of industrial uses. The next is methylated spirit. Methylated spirit contains 95% of ethanol and 5% of water. Methylated spirit is used in spirit lamps. It is used in camping stoves, and it is also used as a solvent as a stain remover. So these are the uses of methylated spirit. The next is power alcohol. Power alcohol is a mixture of petrol and ethanol, which is used as a substitute for petrol. So it can also be used as a substitute for petrol when it is mixed with petrol. The next is rectified spirit. As we have seen earlier in the preparation of ethanol, rectified spirit is a mixture of 95.5% of ethanol and 4.5% of water. It is used for preparing the medical tinctures, and it is also used in household liquors. When we go to the hospital for taking an injection, the area is cleaned by using some liquid, that is this rectified spirit. It kills the germs in the area and makes it clear for the injection to be taken. So this is the use of the rectified spirit. So we have seen here what are the uses of ethanol in our day-to-day life, and ethanol is a very important compound of carbon which we come across in our daily life. Let us see the next important compound of carbon, which it is a carboxylic acid, and among the carboxylic acid we are going to see about acetic acid or ethanoic acid. Carboxylic acid functional group is COOH. The formula of acetic acid is CH3COOH, which is its common name, and the IUPAC name is ethanoic acid. We have learnt about the IUPAC naming in the previous class. So actually this acetic acid is present in vinegar. Vinegar contains acetic acid. For ethanol or ethyl alcohol, we saw that the method of preparation was by fermentation. How it is prepared from sugarcane juice, that is molasses. The preparation of ethanoic acid is from ethanol. When ethanol is made to undergo oxidation in the presence of either alkaline potassium permanganate or acidified potassium dichromate, then ethanoic acid is produced. So it is a one-step preparation. and it can be prepared in the laboratory by this method, or the manufacture of ethanoic acid itself is by oxidation of ethanol. So, ethanol, the formula of ethanol is CH3, CH2OH. When this is made to undergo oxidation with potassium permanganate alkaline solution or acidified potassium dichromate solution, acetic acid or ethanoic acid, whose formula is CH3COOH, is produced. So, this is how ethanoic acid is produced. It is a colorless liquid. Now, what are the physical properties of acetic acid? It is a colorless liquid, but it has got an unpleasant odor. The smell of vinegar is the smell of acetic acid. It is having an unpleasant odor, and it is sour in taste. This is also miscible with water in all proportions, and it is having a high boiling point. When acetic acid is cooled, it forms ice-like flakes, which you can see in your picture, and it gives the appearance of glaciers. Therefore, this is called as glacial acetic acid. Acetic acid, which is at a low temperature, which gives the appearance of glaciers, is called as glacial acetic acid. Let us now see the chemical properties of acetic acid. Acetic acid reacts with metals to give rise to the metal ethanoate with the evolution of hydrogen. We are given two metals. The first one is zinc. Acetic acid reacts with zinc to give zinc ethanoate and hydrogen. It reacts with sodium to give sodium ethanoate and hydrogen. So, the hydrogen in the acid is replaced by the metal. The second is its reaction with carbonates and bicarbonates. It reacts with carbonates and bicarbonates to give out carbon dioxide. The carbon dioxide is evolved, and this gives a brisk effervescence in the test tube in which the reaction is done. Acetic acid with sodium carbonate will give sodium acetate, carbon dioxide and water, and acetic acid with sodium bicarbonate also will give sodium acetate, carbon dioxide and water. It is the evolution of the carbon dioxide which is responsible for the brisk effervescence. Next is the reaction of acetic acid with base. Here the base which we have taken is sodium hydroxide. We know about neutralization reaction in which an acid reacts with a base to give salt and water. So, acetic acid reacts with sodium hydroxide, which is the base, to give rise to sodium acetate and water. The next reaction is the decarboxylation reaction. Decarboxylation means removal of carbon dioxide. Dehydration means removal of water. Dehydrogenation means removal of hydrogen, and decarboxylation means removal of carbon dioxide. When the sodium salt of ethanoic acid is heated with soda lime. Soda lime is a mixture of calcium oxide and sodium hydroxide. It is a mixture of 3 parts of sodium hydroxide and 1 part of calcium oxide. So, when a mixture of sodium acetate and soda lime is heated, we get the formation of methane. Methane is given by the formula CH4, and the byproduct is sodium carbonate. So, this reaction is called as decarboxylation. Decarboxylation means removal of carbon dioxide. So, these are a few reactions of ethanoic acid. Let us now see what are the uses of ethanoic acid. Ethanoic acid also has got very important uses, like we have seen for ethanol. It is used in the making of dyes, plastics. You can see a number of plastic items. So, for the preparation of plastic, different types of plastic, ethanoic acid is used. It is used in the preparation of dyes and paints. So, dyes and paints which we come across in our day-to-day life, it is a product of ethanol, and in screen printing also ethanoic acid is used. Ethanoic acid is used in the preparation of pharmaceuticals, that is in the preparation of a large number of medicines. And when rubber is tapped from the rubber trees, the latex is converted into rubber by using acetic acid. Acetic acid, when added to the rubber latex, it will coagulate it and the rubber is separated from the rubber latex. So, acetic acid is used for this purpose, and acetic acid also is used as a solvent for in the laboratories for many chemical reactions. So, these are the uses of acetic acid or ethanoic acid. Let us now see the uses of a few organic compounds in our daily life. A person has to live with organic compounds. In our day-to-day life, from the time we are born till the time of our death, we have to come across organic compounds in our day-to-day life. Hydrocarbons. What is the use of hydrocarbons? For the preparation of fuels. Our LPG gas is a mixture of hydrocarbon. It is used as a raw material for the preparation of a number of compounds, and hydrocarbons are also used to prepare polymeric materials. So, hydrocarbon means it contains only carbon and hydrogen. So, these are having these uses. When hydrocarbon is replaced by a OH group, we get an alcohol. Alcohols are having a wide variety of uses. To mention a few, they are used as solvents. We have seen about ethyl alcohol, which is used as a solvent, and they are having the antiseptic property. They are able to kill germs, therefore they are used for antiseptic property. In the medical field, they are also used as raw materials for the preparation of a large number of compounds. Aldehydes are used as disinfectants, and they are also used as raw materials for preparing a large number of organic compounds. Ketones, they have the CO group. They are used as solvents and they are used for removing stains. As stain remover, our nail polish remover contains these ketones. That is why it goes off very easily. They are stain removers. They are solvents, so they dissolve organic compounds. Ethers, which is a functional group containing oxygen in the center with alkyl groups on both sides. It is used as an anesthetic agent. Anesthetic agent means something which relieves us of pain. That is what we say, anesthetic agent. So, ethers are used as anesthetic agents and they are also used as painkillers to help us forget the pain, to remove the pain from us. It is used as a painkiller. And esters, which is COO functional group, it is present in cooking oils and in lipids, that is in fats. So, cooking oils, the vegetable oil which we use in our day-to-day life, it is nothing but esters. And the lipids also, the main component of lipids is esters. So, these are a few uses of organic compounds in our daily life. As we know, organic compounds are thousands in number and the number increases day by day as more and more new compounds are being produced and each one is used by us in different ways. So, that is why we say the compounds of carbon are very important in our day-to-day life. So, today we have seen about two important compounds of carbon, ethanol and ethanoic acid. We have seen what are the properties and what are the method of preparation and also what are the uses of these two compounds. All this we have learnt in this unit. I wish you all the best for your future. Thank you.